So example number 4 for multiplying matrices is an example of another one that you need to keep an eye out for, because you're going to look at this, you'll be like scratching your head trying to figure out like, wait, I'm confused, I don't know what I'm doing. But you're taking A times B. A has 2 rows and it has 4 columns. B is a 2 by 2. The number of columns here is not equal to the number of rows here. So this problem is not possible. So just because I said find A times B does not mean it's possible. So there's actually nothing for me to do here, okay? But you have to understand how matrix multiplication works, or you're not going to realize that it's not even possible, okay? But write out the dimensions. The second dimension of the first matrix and the first dimension of the second matrix have to be equal, or you cannot multiply them together, okay? Not possible. So now I've got some other ones just to kind of go through and show you some things that you might see. So this is asking me to do A times B. We already talked about this before. B times A, even though I just switched the order, it's not commutative, so you're not going to get the same answer. What do you think this means right here? If it says A squared, it means you're taking A times A. So you're just multiplying the matrix times itself, okay? So you would write it out that way. So like in the first one, when I'm doing AB, I have matrix A, which is 2, -1, 1, 4, and matrix B, which is 0, 0, 3, -3. I'm multiplying those together. This is a 2 by 2, and this is a 2 by 2. So it is possible to do. The remaining dimensions is that my answer is also a 2 by 2. So I'll have 4 elements when I'm looking for that. When I'm doing the second one, B times A, that means I have 0, 0, 3, -3, and I'm multiplying it by 2, -1, 1, 4. This is a 2 by 2. This is a 2 by 2. The inner dimensions are the same. So it's possible the remaining dimensions are 2 by 2, so that means my answer is going to be a 2 by 2 as well. Now this is working out this way because these are both square matrices. They both are matrices that have the same number of rows as they do columns. So when you have that, you could switch them around, and it's always going to be possible if you're multiplying 2 square matrices together that have the same dimensions. So basically in this first one, again, just following this pattern of I'm taking this row times this column. So 2 times 0 is 0, 2 times 3 is 6. So when I multiply that row and that column, I get those 2 products, the total is 6. Then I multiply by the second column, so 2 times 0, and 2 times -3 is -6. Sorry, not 2 times -3. I hope if I multiply the right thing together. Come on, board. There we go. I am multiplying -1 times -3, that's 3, so that would be a +3. Then I take now second row times each of those columns. So the first one, 1 times 0 is 0, 4 times 3 is 12. 0 plus 12 is 12. Multiply it by the second column. 1 times 0 is 0, 4 times -3 is a -12. That comes out to be -12. Okay, so row times column, row times column. Just repeating that same process over and over again. It's supposed to be 2 times 0 is 0, -1 times 3 is -3. That's where I went wrong. -3. There we go. All right. Great. I'm glad I totally screwed that up. See if I can get this one right. Row times column. 0 plus 0. 0. Multiply this column. 0 plus 0. 0. Now I take this row times each column. So 3 times 2 is 6. -3 times 1 is -3. I get a +3. And take this row times the second column. 3 times -3 is -3. And then I get a -12. So I think I get -15. So the last one will be to do a times a, or a squared. So I'm taking 2, -1, 1, 4, and I'm multiplying it by the exact same matrix. Again, 2 by 2, 2 by 2, same dimensions it's possible. My answer is going to be a 2 by 2. So I'm multiplying row times column. I've got 2 times 2 is 4. -1 times 1 is -1, so I get a 3 there. Multiply that row times the second column. -2 and -4. That comes up to be -6. Moving on to the second row. Row times column. 2 and 4 is what I get for my two products. That's 6. Multiply it by the next one. I get -1 and 16. So I get 15 there. So that would be going through and multiplying each of those together. I think we're about out of time. So we'll stop there for today. Try the next one on your own.